Welcome to this presentation, Introduction to SSH Keys, from the U.S. National Science Foundation Access Program. My name is Joel Adams, and I'm presenting on behalf of the Access Support Award at the University of Kentucky. For those unfamiliar with Access, it's an NSF-funded collective geographically distributed across several U.S. organizations and institutions. You may be wondering, what is SSH? It's an acronym for the Secure Shell, a protocol suite that lets you communicate securely across an insecure network. Using SSH, if you send data across the network, the data gets encrypted at the sender. The encrypted data then gets transmitted across the network to the receiver, and the receiver decrypts it, all transparently to the user. So why is SSH important? Well, from your computer, SSH lets you log in to a remote access system. It also ensures that only approved devices are used, and it addresses some of the security vulnerabilities associated with managing multiple passwords. How does SSH work? The SSH protocol uses two keys to encrypt and decrypt data: a public encryption key that you can openly distribute, and a private decryption key that you must keep secret. SSH relies on special mathematical encryption algorithms that ensure that if a message is encrypted with the public key, it will be impractical to decrypt that message without the private key. Let's use an analogy to illustrate this. Suppose we have some data represented by our red box here. Encrypting that data is like putting it in a lockbox, and then using the public key to lock the lockbox. The lockbox can only be opened by someone with the private key. Without the private key, cryptographers estimate it would take a cutting-edge supercomputer thousands of years to decrypt the data, assuming the encryption algorithm is a good one. How is this public key encryption useful? SSH uses public key encryption to let you use your computer to log into a remote system, such as an access resource. The fancy name for this is authentication. SSH lets you authenticate your identity to the remote system. To do this, SSH uses a client-server architecture. The user runs an SSH client on their computer. That client interacts with an SSH server running on the remote system. To illustrate this in a simplified way, suppose Anne wants to use her computer to connect to a remote system. If she hasn't already done so, Anne generates public and private keys on her computer. She then uploads her public key to the remote system, storing it in a special file in her account. Now, if Anne wants to connect to that remote system, she uses an SSH client, which sends a connection request to the SSH server on that system. When the SSH server gets this request, it generates a large random number. It then encrypts that number using Anne's SSH public key. And then sends that encrypted number to the client on Anne's computer. There, on Anne's computer, her SSH client uses her private key to decrypt the number. Anne's client then sends that number back to the server, which compares it to the number it generated. If the numbers match, the server creates a secure channel to Anne's client for her session, and Anne is off and running. I should mention that all Anne does is tell her SSH client the name of the remote server to which she wishes to connect. The rest of this activity happens behind the scene, invisibly to Anne. I should also mention that to keep this simple, I've glossed over lots of details. For example, the SSH server sends its public key to Anne's SSH client so that her client can encrypt everything it sends to the server. The SSH handshaking protocol is much more complicated than I've described to keep it secure against different kinds of attacks. But this should give you a basic idea of how SSH uses public key encryption for authentication. In summary, SSH stands for the Secure Shell Protocol Suite, which provides secure communication across an insecure network. Access uses SSH key-based authentication. This is sometimes called asymmetric key authentication because the public key can be freely shared, but the private key must be kept secret, stored securely on the computer from which it was generated. SSH employs a client-server architecture. To connect to an access resource, a user uses an SSH client, which connects to an SSH server running on that resource. Finally, before a user can connect to an access resource using SSH, they must first generate public and private keys on their computer and then copy their public key to the resource. In the remaining presentations in this playlist, we'll walk you through these steps.